All right, so things to think about when you're trying to graph a line. You want maybe a y-intercept. You want maybe 2 points. You want to think about slope. They're all things that you need to think about when you're going to graph a line. So if I'm thinking slope, all right, thinking caps on. Anybody got a guess as to the equation for slope? It's been a while, I know.
Y over x.
It is the y's over the x. Yeah, let's take it from there.
Y equals mx plus b.
Okay, that's going to be, I'm going to put that off to the side here because y equals mx plus b is going to come into play with what we're going to do. So that involves the slope. But Angela was saying it's the y's over the x's. Yeah.
Change in y over change in x.
It is change in y over change in x. If I were to put that in fancy pants math lingo, they usually use a triangle, meaning change. Change in y over the change in x. Isn't that kind of funny how they do that with a triangle? But that's what they do. All right, so let's think about that a little bit. It means I have to take the y values, y2 minus y1, and put them over the x values, x2 minus x1. Does that ring a bell? Now here's a story, and you might be one of these kids, because this happens a lot. Sometimes people forget, are the x's on top or are the x's on the bottom? Kind of hard to remember. Some kids get really confused by that. But you were on it when you gave me that. It is really the y's over the x's. So here's my trick to remember that. It's a picnic table. Here it goes. Here's my picnic table. I've got, you know, a picnic table has the legs like this, right? X's are on the bottom. All right, I'm going to go uneducational for a minute. So take me off the grid for a second of being an educator. I have martini glasses on top. Nice. Right? Now, purely for remembering purposes, the martini glasses have to be on top of the table. The table has to be held up by the x's, okay? So a way to remember, if it's going to help you remember how the slope formula goes, that's the whole purpose. Okay, so perfect. My y2 minus y1 over x2 minus x1, that's what I want to do. So I'm going to take my points and I'm going to label them as such. And it does not matter which one you pick for your x1, y1 or your x2, y2. Your answer will come out the same either way. So I'm just going to take my first point here, this x1, make this x1, y1, make this guy x2, y2. And then I'm going to just plug in the values, right? Just put them in. So in my case, y2 is a 0, y1 is a 3. In the bottom, x2 is a negative 4, and x1, it has to be minus, x1's a negative 1, so watch that. That guy's got a double negative going on. And so I'm looking at, solving that out, figuring out my slope, m equals 0 minus 3 is a negative 3, negative 4 plus 1 is a negative 3, and negative 3 over negative 3 is a 1. So this one's pretty. It comes out with a nice slope. Slope is 1. But then I need to figure out what the equation is for the line, right? It isn't just the slope. And we have this formula over here that we're really kind of working with, y equals mx plus b. I know my m piece. My m piece is 1. I need to figure out the b piece. The b piece is your y-intercept. And so you're going to pick one of the points, whichever one you choose. And you're going to use the x and the y from that point to fill in so that then you have these three pieces all with numbers in there and you can tell what b is. So that's our direction. Then the choice is which point do you want to pick. Now you pick the prettiest one to you. What do you think? Any guesses of what you would want? Negative 1, 3 or negative 4, 0?
Negative 1, 3.
All right, they chose negative 1, 3 in the room here. We're going with it. My y is 3. My m is 1. My x is negative 1. And I want to know b. And so I'm just going to solve it out. 3 equals negative 1 times 1 is negative 1 plus b. And then I'm going to swing that negative 1 to the other side. I get 4 for my b. And then I put the equation together. Y equals mx plus b. So y equals m is 1 x plus b is 4. Now 1x is the same thing as x, so you could have that as x plus 4 without the 1 there. It's understood to be there if you don't have it. But it's not wrong to write it in either. Cool, there it is. There's our line. So we go to graph it. Now you've got a couple of options on how to graph it. You can just plot the 2 points and connect them, right? That would graph the line. Or you can use the fact that you've got b as your y-intercept. Let's try it that way because we'll be extra smart. 1, 2, 3, 4. My y-intercept is here. And the slope is 1. That means I rise 1 and I run 1. So I'm going up 1 and right 1. Now, however you did this, whether you plotted just the 2 points they gave you, you should have that same line going on. And so did we answer their question? Given the points, find the equation of the line and graph it. We did. Okay, let's try another. Now, given these 2 points, 2, 1, and 6, negative 3, find the equation of the line and graph it. So I'm going to give you a chance, a head start. You start and I'll start and we'll see if we match. Do the same exact thing we did up above. All right. Thumbs up? You okay? Okay. Questions from anybody at home? All right. Then we're getting into, that's talking about lines. The other things that we're going to do in this section is talk about graphing parabolas and absolute values. And so we need to look at what they would look like and how they shift when you put numbers in their equations. So that's going to be the next thing here. You got to start out, though, with what's the basic look of a y equals x squared graph? If it's just y equals x squared, can you think about what that would look like? You're close. Yeah, the answer was a v. V's are going to be the absolute values. Yep, but you're on the right road. If we think x squareds, I think we did them when we were looking at the basic functions back in Unit 2. But an x squared is a happy parabola, right? He's the happy parabola where the vertex is at 0. So when I'm looking at this number 3 on this sheet, you've got a regular x squared graph goes like this. He is a happy parabola with the vertex at 0. What do you think happens if I put a negative in front of that? Mr. Happy Parabola. Yeah. My folks in the classroom are telling me, yeah, he goes down upside down, right? He turns upside down. So if you had a negative, and that'll pop up here and there. If you have a negative, he's no longer happy. He is sad. He's flipped over. Okay, so just to keep that in mind, let's flip the page and let's see what happens with some of these numbers that we're going to look at here. So for our graphing purposes, they're going to leave it in this type of a form where you have a grouping that's squared and then a plus 2, and you don't want to FOIL it out. Because if you were to FOIL this out, you would end up with like x squared minus 6x plus 11. And that doesn't tell you where it shifts. You want it to be in this form because when you see this form, it makes it really easy to see how that vertex has changed. Because this number that's on the outside, this number on the outside moves it up or down. So this 2, because it's a positive 2, that means I've moved it up 2. So the number on the outside is an up or down type thing. And the number inside the parentheses moves it left or right. So maybe I do something like this up above to show you. Inside the parentheses is a left or right movement. And then outside is going to be an up or down. Up if it's positive, down if it's negative. And here's an interesting thing that comes up with this. See this 3 in parentheses? And I'm telling you it's moving it left or right. Which direction do you think that should move it, the x minus 3? Take a gut guess.
Right.
Yeah, the gut guess is right. And that is actually not what it does. Now that seems really counterintuitive to what you would think, and I agree with you. If I see an x minus 3, I'm thinking right 3. That really is my first instinct, just as you're thinking the same way. But here's why it is actually, this means it's a left 3, and I'll show you why. If I take x minus 3 and I set it equal to 0 and solve for x, I get x equals 3, which is a positive 3, which moves it in a positive direction, which is why it is actually, oh, did I just say that wrong? I said that wrong. Did I say that wrong? Yeah, I did. Ooh, catch me. It is right. Yeah. Woo, winner. What are you thinking? All right, right. Here's why it's right. Because you got a positive 3. It's moving in a positive.
Yeah.
Where are you like looking at me going, wait a minute, what is she talking about? Don't ever hesitate to stop me. I've been teaching for 26 years and I can be wrong and I'm all right with that. We all make mistakes even after all this time. Yes, it's a right movement. If I'm going left, it's it's a plus, okay? Because then it would solve out to be a negative value and then it would be moving left. Whew, that was rough. Okay, up to right 3. Well, where was the vertex to begin with? For a regular old x squared graph? At 0, 0, right? But you're going to take that vertex and you're going to move it up 3 and up 2 and right 3. So right 3, up 2. Here it is now. Put a dot there. And then I'm going to draw my parabola. There it is. Same parabola, it just has been shifted. And it's shifted by these numbers that you've got in your equation. So again, you don't want to FOIL it all out because then it's in a quadratic form that's not going to help you to know how it's shifted. So in this form, it's nice because it tells you exactly where you're moving. So let's think about that for a minute for the next one, for number 5. If you have x plus 4 in parentheses, parentheses is left or right, this one's a plus, yeah.
Do you have another blank piece of paper? I can fill this one.
Yeah. I have it, well, here's a white one.
Thank you.
You're welcome. Oh, you probably came in late because the papers are right, the notes are there if you want them, but you're already on it. Okay. Anyway, you probably at home have thought about how this thing shifts. If it's an x plus 4, where's it going? That to the left, to the left. So he's going left 4, and the minus 3 at the end is a down 3 because it's negative. But wait, there's more. Right? You've got this negative out in front. And remember we talked about what that does to the graph. Instead of it being right side up, he's now flipped over, he's upside down. Let's see if we can do this. It was at 0, 0. I'm going left 4, 1, 2, 3, 4, and down 3. So there's my vertex now, but now I'm going to flip him upside down. He is no longer a happy guy. All of us with our doors open, I can hear everybody else teaching. Okay, that's parabolas, but the same thing holds with absolute values. Instead of you having a vertex, now you have that point that the absolute values come down to. And so that point is normally at 0, 0. Here's your happy absolute value graph. He is pointy at 0, 0, and there you go. Oop. But again, what happens if you put numbers in his place? Just like you just did with the parabolas. If you toss some numbers around, it's going to shift. And the shifting works the same way. If it's inside the absolute value, it's left or right. If it's outside the absolute value, it's up or down. And if there's a negative in front, it flips upside down. Goes pointy up. All right, so let's try a couple of these. Then we're going to try something else. So sketch the graph of the absolute value of x plus 1 minus 3. Well, inside is a lefty-righty. This guy's going left by 1. The minus 3, he's going down by 3. And so you're going to take that pointy place and you're going to move it that way. So left 1, down 3. Put your dot. This one is a positive absolute value, so it's going to be your normal V. And again, you're sketching these. They don't have to be perfect. You're just giving the general look of what they should be. All right, see if you can do number 8, and we'll see if we match. He almost went off the grid. Good, got the idea? Okay. So here's a classic SAT question. Have you guys taken SATs yet? Not yet, but they're looming, I'm sure. I don't even know with COVID if they're doing them at the moment. I don't know.
My mom keeps asking about it.
Yeah, I bet. I'd be asking too, as the mom, wondering if they're doing them. I know they're planning to do the AP tests, like on the computer this year. So we'll see how that goes. But I'm thinking, since it's all College Board, I wonder if they're going to do SATs that way as well.
Are the AP tests optional?
Are you taking an AP class?
Yeah.
Yes, they are optional, but you should have already signed up for them at this point.
Oops.
No? Yeah, yes,
I'm
no?
already accepted to college, so
Yeah.
I don't really need.
Need the AP credits?
Yeah.
What do you have AP? What's your AP class?
AP biology.
Would you want to opt out of biology in your college?
Nope.
Yeah, there's a lot of time, we're talking AP stuff. Sometimes when you take, like my kids take AP, I teach AP Calc, but not every kid is like, it's not great for every kid. I've got a lot of kids that do direct engineering, like they're going right in for engineering. And the engineering calculus is so different than regular calculus that I teach because it's much more applied to engineering. So for that kind of a child, it wouldn't be worthwhile for them to take the AP test and then opt out of it because then they're not learning the right kind of calculus they should. So anyway, my point is that it's not for everybody. It's all right if you don't take it. All right, so my question number 9, and this is an important one. This is my SAT question. If you have negative 3 squared, is it 9 or negative 9? What do you think, Angela?
Negative 9 because there's no parentheses.
Negative 9 because there's no parentheses is her guess. Anybody think differently? It's usually pretty controversial. Anybody think a positive 9?
Wait, yeah.
Yeah, so we've got some positive 9s in the class and negative 9s in the class. And that doesn't surprise me because this is kind of one of those issues. Does anybody have are you pretty adamant about what your answer is?
It's definitely positive.
It's definitely positive and a definitely negative. Okay, we got both ends of the spectrum in here. All right, so here's my answer. The answer is, it's actually the -9. And here's why. And this catches everybody. This is classic. And funny enough, your calculator, it even gets your calculator. If you put -3 squared in your calculator, guess what it normally spouts out is a 9, positive. Even your calculator gets it wrong. But here's why it's wrong. Remember, please excuse my dear Aunt Sally? Yeah, so you got to do exponents, right, before you do anything else. So if I exponent first, that means that this is going to be a 9. And then I'm attaching that negative sign to it. So the actual real answer is the -9. Exactly right. So -9 it is, and it's because you got to please excuse your dear Aunt Sally, which means you're going to square that, and that becomes the -9. That comes up in some of the problems that we're going to look at, okay? So just remembering that, how that works. All right, so that's the end of that worksheet, and that was just kind of to get us warmed up with some graphing things. And then I want to go to this worksheet, and again, if you're at home, you can just follow along on paper.
I'm really smart this time.
Yeah, make it easier on yourself. Okay. Now the next thing we're going to look at with this one on this piecewise function worksheet, we're only going to do a little bit of this. We're not going to get too far into this. Actually, just the front side, to be honest. So piecewise functions are made up of 2 or more functions, each with its own domain. It's like it's chunked up. It's like in chunks. It's in pieces, right? That's the whole idea, piecewise functions. There you go. So this is a picture of a piecewise function. You have a straight line that goes from -infinity to 0, and then it picks up again a different line from 0 to infinity. So they have different domains. And that's what we're going to say with this. So my function is made up of 2 separate lines, and I'm going to see if I can figure out what the equation of those lines are. This is what we're going to practice with again when I see you on Tuesday as well, is coming up with these equations. But if I look at this first equation, I know it's a line, and I know that lines have to be y equals mx plus b. Make sure you can see me. Okay, so my first line, if I'm talking about this first one, reading it from left to right, I need to know, in order to be able to come up with the equation for the line, I need to know the slope and I need to know the y-intercept. And so I'm totally ignoring this part. I'm only looking at this line over here. And I want to know what's its slope and what's its y-intercept. Yeah.
The slope is -2/3.
It is. I 100% agree with your 2/3. You have to rise 2 and run 3 to get to the next point.
I'm
So,
just confused because like it starts at the right and then it goes down. So I don't know if it's
so the question that's coming up, we agree that it's 2/3. So I'm going to put it over here. The slope is 2/3, but now the discussion is it positive or negative 2/3? So let's go back to slope dude, right? If you think slope dude, this one you're going puff, puff, positive up to the hill, right? So it's the positive one. It's the rise over the run. So I had to rise +2 and run 3 to get there. So this one's going to be a positive 2/3, and then there's an x. And then I need to know what b is. Well, b is the y-intercept. And the fact that it's an open circle doesn't change the fact that it's where it connects to the y-axis. It's an open circle point. So it's still a -1. So I guess I want to go back here and change my plus b to a -1. Now we're going to talk about that open circle in just 1 second, because that's got to come into play somehow, right? So I'm putting it, normally you'll see piecewise functions have an f of x on the outside with an equals and a fancy pants bracket that includes all those different equations that might belong there. So the equation we're saying is 2/3 x minus 1, and then there's a comma when you see these piecewise functions. And the comma, after the comma, comes the domain. Where does this thing exist? So it's everything that is less than, what number? 0, right. It's everything less than 0. It starts at 0 and goes left. Does it include 0? No, that's your open circle. So the fact that it's an open circle comes into play with your inequality. It doesn't come into play with the equation of the line. So we have now said that this part of the graph is the line 2x minus 1 when the x values are less than 0. And that represents this line right here. All right, now we're going to go for the second line. That's this guy here. Let's do the inequality first, because that's kind of the easy thing. This guy starts when x is 0. Does it include it? Closed circle?
Yeah.
Yeah. And it's got to be everything greater than or equal to 0. It starts at 0 and goes to the right, keeps going. Now let's think about the equation. You need a slope, you need a y-intercept. Did I do? Yeah, no, I'm good. I'm good. I thought I did the last one wrong. I didn't. This one, you've got a slope that is 1, right? 1x, you don't necessarily need the 1. And you have a y-intercept, where's it hit the y-axis at 3. However, is that a positive slope or a negative slope? Yep. This one's nice. Negative. Yeah, he's going down the hill. Okay. We're going to practice some more with that when I see you again on Tuesday. But for now. Now here's the rest of the class. Here's what we're going to talk about. We're going to evaluate piecewise functions. And so you can see they want us to find f of 0, f of negative 3, and f of 4 from this set of equations. So here's the story. It looks very complicated. You're looking at, oh my gosh, there's so many different equations I can choose from. Which one am I supposed to pick? You're always only picking one equation. You're only using one. You're never using more than one. But the question is, which one do you pick? And the one you pick is the one where this x value is. So the first one is f of 0. I go to the inequality. It's the inequality part that tells me which one I'm going to use. F of 0. So I have a choice. Am I using equation number 1 or am I using equation number 2? And so I got to think about that. Which one includes 0? Equation 2. All right, that's what you're going to do. So to find f of 0, you're going to plug it into the second equation, negative 1 times 0 plus 3. And so I get 3. There it is, f of 0. All right, f of negative 3. I have two choices. It's either equation number 1 or equation number 2, wherever negative 3 falls. So I am at 0 and going left. I'm at 0 going right. Negative 3 is to the left. So I'm using equation number 1. 2/3 times negative 3 minus 1. All right, multiplying fractions is a little funky, right? But if I do this, I have negative 6 on top over 3. Negative 6 over 3 gives me a negative 2 minus 1. And so my answer is a negative 3. Some of you might have thought about these 3's canceling. Same idea. You get negative 2 minus 1, so you get negative 3. So however you were thinking about that. Does anybody want me to show you the work for that? We okay? All right. Last one, f of 4. I've got to figure out where 4 is. Is 4 less than 0 or greater than or equal to 0? Which one is it?
Greater than.
Right. So it's going to be equation 2. So here I go, 4. Negative 1 times 4 plus 3. Negative 4 plus 3 gives me negative 1, and that's your value. So evaluating piecewise functions. Again, you're only using one equation, and you decide which one you use based off of the inequality that you're looking at. All right, so here's the next set. They changed up the equations on us. I have now 3 equations to choose from. So it's 2x plus 8 when your x values are less than negative 2. It's x squared minus 3 when your x values are between negative 2 and 3. And then it's the square root of x plus 3 when your x values are greater than 3. So you have 3 choices now based off of this particular function. So the first value you have is a negative 4. Your question is, are you using equation 1, 2, or 3? Got to figure out where negative 4 is. Is negative 4 less than negative 2? And I'm seeing, think about negative 2 on your number line. Where's negative 4? To the left, right? So that means that, yeah, you're going to be using the equation number 1. I'll put a little number 1 next to this. You're using equation number 1 and you're plugging in your negative 4. So 2 times negative 4 plus 8. And then you do out the math. So negative 8 plus 8 is a whole lot of nothing. That one came out to be 0. All right, the second one is f of 6. I've got to figure out where 6 is. Is 6 part of equation 1, 2, or 3? And so I'm looking. 6 is pretty big. 6 is bigger than 3, so it's got to be equation number 3 that you're using this time. Plug it in. Square root of 6 plus 3. And you're like, that's pretty cool. That's a square root of 9. A nice easy one, right? So this guy would be plus or minus 3. Now this one gets a little more dicey, the third one, negative 2, right? Because technically I have 2 negative 2's to choose from. Negative 2, here this guy goes with the 2x plus 8, but negative 2 is also part of the x squared minus 3. And remember, I'm only allowed to use one equation, so I've got to decide, is it equation number 1 or is it equation number 2? And it's all based off of, is it equal to or is it not? So if I go back up here, negative 2, this works if it's negative 2 or anything less than that. So you've got to use equation number 1 for this guy because that's where the equal to part is. So here I go, 2 times negative 2 plus 8. Negative 4 plus 8 gives me a 4, and there's my answer for that third one. So watch the equal to signs on those inequalities. The last one like this is f of 0. Does 0 go with equation 1, 2, or 3? I'm looking, where is 0? 0 is not less than negative 2. Is it between negative 2 and 3? And you're like, yeah, that's where he is. So I'm going to put it in the second equation. I have 0 squared minus 3 gives me negative 3. And that is how you evaluate piecewise functions. So, last thing I want you to do is see if you can do the try it. Just the rest of this front page here. These try it problems. See if you can, and then we'll see if we match. And then I'm going to set you free for the day. Anybody at home have questions?
Do you want us to start the back of the test?
Yeah, hold on one second. I'm going to give you the answers to this, make sure you're good to go. then I'll let everybody out. Okay, so here's hopefully what you got. The first one should give you 6. The next one's -1. And then 3 for the third one and 3 for the fourth one. So I'm seeing thumbs up in the classroom. Everybody else okay? There's one last thing before I release you. I'm going to let you out a little bit early. And it's this. On the back side of that sheet are these problems, and we didn't look at anything like numbers 5 or 6. I just want to show you real quick what they're talking about. So they're giving you a piecewise function in number 5. All they want to know is what's the coordinate. They're just writing it in a different way. They didn't give you the algebra steps to do it. This is from looking at the graph. So really you're just looking at what the coordinate would be. So like 5a, f of -1. If I go over to -1, they want to know what's the y coordinate that goes with that. And you can see at -1 it goes through 0. So your answer for 5a is 0. All you're doing is reading the coordinates off the graph. Okay? So don't let that throw you for a loop when you go to see that. So your task is to answer questions 1 through 6. This back side of this sheet, it's on our classroom page for those of you that are at home, and that is due by Monday. You can see it's not going to take probably that long to do. It's pretty quick and easy, and then just turn that one in and we are good to go. When I see you again on Tuesday, we're going to be looking at finding equations from graphs, some practice with that, some more practice with that kind of stuff. If you are logged in, you are free to go and have a good weekend. And if you're with me, you can work on your 1 through 6 and get it done. All right, kids, be good. Yeah.
Do the same rules apply, like if it's like an open circle, it doesn't exist? Like the coordinate?
If it's, well, which one are you looking at?
C on number 5.
F of 1. So is there anywhere at 1 a closed circle?
Yes.
Right, then you're going to have whatever that value is your answer.
Okay.
Yep. If they were both closed circles, though, Angela, then it would be a doesn't exist. I'm sorry, did I say that wrong? If they're both open circles, then it's not going to exist. Yeah. Yeah.
What about 6C?
6C. F of 1. So I go to 1.
Oh, wait, never mind.
Did you catch that?
Yeah.
But you know which one? How about D?
Yeah.
I think you're thinking D. Yeah, the D one. The D one, that's one of the ones, Angela. If you look at 6D, F of -1, you're not going to have an answer for that. That's a doesn't exist because there's no coordinate there.